Good morning. I think you can start now. Hello, good morning. Can you all hear me?
Yes, sir.
Right. How about the board? Is it visible? Yeah. There was some technical problem. Actually, I asked you all to log in into the same number, so which we have used last time. I think some of you had problems, so I came through another site, right? So next time we will use probably not this one, another new one. Right. Continuation with our lectures. Last time we spoke about the normal distribution. Can you all see the screen? Can you all see the screen? Yes. Last time we spoke about the normal distribution. Starting with the normal distribution. When you talk about normal distribution, this is the notation for the normal distribution, which is giving the probability density function of a normal distribution. Probability density function of a normal distribution is given as such. So whereas we can have the value, random value between minus infinity to plus infinity, right? So that is how the normal distributions look like. If you look at some of the characters of normal distribution, is a bell shape. It is very important, and it is also symmetric about the mean, median, and mode. All these are lying on the same place. So sometimes it is also called as a bell shape distribution or Gaussian distribution. Then to understand the normal distribution, this is a natural distribution. If you look at some characters of normal distribution, from the deviation, one deviation of mean plus or minus the sigma, one deviation of plus or minus sigma will indicate the area, which is 0.683. So as you all know, the probability of continuous distribution is given by the area, the total area under the curve, probability of continuous distribution. So that if you take mu plus or minus 1 sigma, plus or minus 1 sigma, it is comprised of almost 68.3% of the area. Similarly, if you take mu plus or minus 2 sigma, it is comprised of 95.4% of the area, which is actually this area, right? Right. So that area is indicated by mu plus or minus 2 sigma. The third one, mu plus or minus 3 sigma, it is the area which is covering almost 99.7%. So this is the area that we are talking about. In a normal distribution, it covers almost 99.7% of the area, right? So that we have already seen. So that is the special character of a normal distribution. Whereas, since we are unable to calculate the area directly from the normal distribution, we are try to formulate another distribution, which is called as standard normal distribution. So this standard normal distribution is a man-made distribution, right? It is a man-made distribution. So what is the speciality of this standard normal distribution is mean is 0. We are having a mean value of 0 and the standard deviation is 1. So that is the speciality of this, what do you call, distribution. No, metana Right, we will continue. Yeah, so standard normal distribution, mainly standard normal distribution is mean with 0 and standard deviation is with 1. So that is how we define the standard normal distribution. You see, instead of mu, we are substituting 0. Instead of sigma, we are substituting 1. So that is how it goes, right? So what we are trying to do is, all the other properties are same for the standard normal distributions, like normal distribution, bell shape, symmetric, mean, median, mode is at the middle, is symmetric, etc., etc. Only difference is here the mean value is 0, and the standard deviation, which is coming under the area under the distribution, which is equal to 1. So that is sigma. So that is the only difference. That is mainly for us to do the calculation. That is why it is given there. If you look at the normal distribution again, here in this case, mean is same. Sorry, mean is different. So it is shifting to the right side or left side, you can say. Mean is different, but standard deviation or the variance is same, just to say. We have seen this last time. So here mean is same, but standard deviation deviate. If the graph or the distribution become more and more flat, it is having higher standard deviation. You see, this is having higher standard deviation than this black color, than this blue color, right? So what is the speciality? Because we said the normal distribution can be converted into standard normal distribution, so that the area should be kept same for both. So look at here, the mean value is mu. Mean value, can you remember, mean plus or minus sigma. This is our condition for the first range, all right? So here, what is mean? In a standard normal distribution, mean is 0 plus or minus 1. So plus or minus 1 mean that is the range, minus 1 to plus 1. So the probability of z in between minus 1 and plus 1 will have the same range as earlier, similar to the normal distribution. So this is 68.3% or 0.683. Similarly, mu plus or minus 2 sigma, right? Mu plus or minus 2 sigma. 2 sigma mean 2 plus or minus 2. If it is plus or minus 2, definitely this is the range of the value of z, minus 2 to plus 2. So that is here 95.4%, and this is 99.7% if the mu is plus or minus 3 sigma, right? So that is how it goes, all right? So we don't change the characters of the normal distribution here when you develop the standard normal distribution. Last time we tried to learn a little on standard normal distribution. I couldn't remember. I gave you some homework to find out the probability. Anybody has information about that? I couldn't remember exactly. So anyone having the information about the probability value? So here,
so we did that.
huh?
So we did that in previous class.
Yeah, but did I give you some homework?
Those are all done in the class.
Okay, all done in the class, right? Right. Now, if you look at the probability here, so this table is it gives the probability on the left side. So suppose, let's say this is the z distribution, right? This is the z distribution. This is the value of 0. Suppose if I want to find out what is the probability enclosed less than the value of minus 1, how do we write probability of less than minus 1? So we can directly read the value from there. Probability of z less than minus 1. What is less than minus 1 area? 0.1.
1587.
0.1587. Right. So that is good. Did I talk about something like this? Probability of z greater than 0.5. Did I talk about that? Two different things. Did I talk about this? Yes or no?
No, sir.
No, right. Because I couldn't remember exactly. Right. Now we can find out all the values on the left side by simply reading the table. Now we may have a chance to look at what is this probability. Again, this is a z distribution. Let's say I want to find out the probability on the right side. Right? Let's say this is a value of 0.5 plus 5. Now you see two different things. So if I write it down in terms of text, find out the probability of z greater than 0.5. Now the story is different compared to the earlier. Earlier, we read the table directly and get the value because it is a left side probability. Here it is a right side probability. Now what we can do? Anyone? Because this table gives only the left side one.
1 minus that one.
The total probability is 1. So we can rewrite this probability of z greater than 0.05 is actually 1 minus because it is a symmetry. Right? It is a symmetry. So that we can write down 1 minus probability of z less than 0.5. We can write like this because total probability is 1. So if you take this away from 1, automatically you will get the probability there. So that is equal 1 minus, find out the probability for 0.05, 0.6915. So what is the answer that? 0.3085. Right? Can you find out the probability of z greater than 1? Find out the probability of z greater than 0. So this is equal 1 minus probability. This probability is equal 1 minus probability of z less than 1. So what is that answer? 1 minus 1 probability z value for 1 841. 841. So get the answer here. That is 0.158. So that is the answer. What about this one? Probability of z greater than 0. What is the answer? Probability of z greater than 0.
0.5.
Yeah, we don't need any table. We don't need any table. Why? Because we know in a z distribution, if you take greater than 0 or less than 0, it is symmetric about mean, which is 0. So definitely this is 0.5, this is 0.5. So no need of any table for z distribution to calculate this probability of greater than 0 or less than 0. Right? Right. Now we will come to another situation. I want to find out the value in between two range of z value. I would say this is minus 0.8, this is 1, minus 0.8 and 1, for example. So I want to, how I can write probability of z greater than minus 0.8 and less than 1. So what is the answer for this? Anyone? How we can write down? How we can write down the answer for this using this table? Because considering the whole area is 1. Considering the whole area is 1, how we can write that? So this is because here we are worried about this area. This is the area, I mean, not this area. I want to find out, even though I have, I want to find out this area. I want to find out that area. All right? So how we can rewrite that? If I get the probability for z less than 1, it will give the area below 1. It will give the area below 1. So that area minus probability of z less than minus 0.8. Do you get the point? So that is the area which indicating less than probability area of minus 0.8. So we can get the value as such. So if you look at the value for that, 0.8413 minus z value of 0.8 minus 0.8. It is 2119, 0.211. So get the answer. Simply solve this answer. Then that is your answer. Any questions? We should know how to read the table. Then only we can move forward to do the conversion. So first we will see how to use the table. Right. Find out the probability of this. You can get the answer here. Probability of z greater than 0.5 and less than, what is the probability? So this we can write it as probability of z less than 2 minus probability of z less than 0.5. So from that, probability of z less than 2 is 0.9772 minus 9772 minus 0.05. What is the probability? 0.6915. Get the answer. Using the calculator, get the correct answer for this and this. So that is how you can find out the probability. Any questions? Any questions? Any questions? Right. Now, one more point on that. Tell me how to find out the probability here. Here my probability is 0.4. My probability is 0.4. This is the distribution. Right? So what is the value of it? So in other terms, if I say probability of z less than a, it is equal to 0.4. Now, other way around. Earlier we want to find out the probability. Now we have the probability. We want to find out what is the z value. Right? We want to find out the z value. Can somebody tell me how to find out this? Directly, this is the probability value. Directly look at the value of 0.4 from the p-value. You don't get it directly, but look at it. There we can get the value. Closer to what? Anyone?
Minus 0.3.
0.5.
Yeah. In between, tell me what are the in between values?
0 minus 0.3 and minus 0.25.
Exactly. So we have, because we don't get the exact probability here, So we are getting in between minus 0.3 and minus 0.25. Take the average. So that is the best way. Take the average because we don't get the p-value exactly for all the p-values, right? So you can take the average, no problem. So what is the average here? So this is your answer. Minus 0.275. That is the answer for A. That is the answer for A. Clear? Find out this. Find out that value and tell me.
Excuse me, sir.
Yeah. Go ahead.
So here minus 0.25 directly give 0.40. But why we put that 0.30 also?
Where?
In this calculation, we get that 0.4 area equals to that minus 0.25. It gives 0.40 and minus 0.3 gives 0.38.
I didn't get your point. Once again.
Why we want to average, sir? Because
can you find exactly this value in P? Exactly.
minus 0.25 directly gives 0.40 something.
40?
Yeah.
4013.
Oh.
Not 40, it is 4013. So there are some values also in it, isn't it? So it doesn't give only 40. If it is giving 40, because if it is 2 decimal, we can take it in that concept. But here we have everything in 4 decimal. You understand? Everything is in 4 decimal. So we'll have to get the average. When you get the average, we can think about it weighted average. That we don't want at the moment. So better to have an average. But as you said, this 0.4 is much closer to the value of 0.25. But not exactly the 0.25. It is much slightly higher than 0.25, minus 0.25. Isn't it? Do you get the point? So that is why we are averaging it. Right? If you put, even in the exam, if you put minus 0.25, we don't ignore it. We accept it because it is assuming that 0.4 is much closer to minus 0.25 compared to minus 0.3. So that is the basis. Do you understand? Do you understand? Yeah.
Yes, sir.
Yeah. Because of that, still we accept. Because you understand the concept. That is why. I mean, that is why we are teaching, right? To understand and keep everybody the understanding. So that is why. So no problem, right? Suppose, let's say, if I have something like this, 3, 9. Is it closer to? Just a second. 3, 9. Let's say if the value is the probability value is 0.39. Now, definitely it is almost in the middle between minus 0.25 and minus 0.3. So now we'll have to take definitely the average. If you simply say minus 0.3, it is wrong. If you simply say minus 0.25, again it is wrong. Why? Because in both sides you have a large differences. Do you get the point? So here definitely you will have to get the average, because look at this is minus 0.3 minus 0.25. So this is the z value, p value. P values are 0.3821, 0.401. So tell me This value is more or less in the middle. It is, isn't it? This probability value is more or less in the middle. So we'll have to take some more of the average of this. But as you pointed out earlier, the probability value, which is P is equal 0.4, which is much closer to this value compared to here. The difference is less. So we can assume this as a value, right? So still it is correct. If you take the average, still that is also correct. So we accept, you understood, because we cannot make for all probability value one single page of document. So if you want to have, then we'll have to have 20-page or 50-page document to have probability values for even 4 decimals, 0.0001 to 0.002 and so on. So that is why everything is assumed, right? Okay. Right. Any other questions? Good. So better to take the average. If you have such kind of values, better to take average. Any questions? Anyone would like to ask any other questions? If not, we will continue. Right? So you should know how to calculate that. Now you see how to calculate this. How to calculate that? So graphically, if you show it in a Z distribution, so here the probability of A is greater than, sorry, Z is greater than A, which is comprised of this area of the probability 0.6. So I want to find out what is the value for A. Right? So how we can handle this? The same thing. How we can handle this? Total area is 1. Right? Total area is 1. Anyone? How to handle this? What is the value of A? What is the value of A? So look at what is this opposite area. What is the left side area?
1 minus 0.6, 0.6.
What is this area? 0.4. That area is, can you all see the color of the pen? Do you see the color of the pen or do you have difficulties? This is a red color. Can you see? Yes or no? Can you see the color? Right. I will
Yes, sir.
Yeah. Okay. So this is 0.4. Fine. So now simply we want to find out the probability which coinciding with 0.4, which we have already done. So find out the area. Sorry, area is already there, 0.4. So find out the probability. So this actually we can say the probability of Z less than A is 1 minus 0.6, that is 0.4. So from that we can find out the A, which is same as earlier one, minus 0.3 plus minus 0.25 divided by 2, which is 0.275 minus. Right? Now, if you have another case, find out the probability of Z greater than A less than B, which is given as 0.9. Find out that. Can you find out that value? So here we'll have to assume that this distribution is symmetric. Based on that only we can calculate. Right? Any questions? Any questions on this? Right. How to find out this value? Interesting, right? We want to find out the area of what is A, what is B. Right. Now, this is the area which is covered 0.9 probability. If it is that, what is this area? Assuming symmetric. What is this area? It is symmetric. Otherwise, you cannot answer for this kind of question. If it is symmetric, what is this area? What is this area? It is
0.05.
0.005.
Exactly. 0.1 divided by 2 because the remaining probability is 0.1. So if you divide that into both places, it is 0.05. This is also 0.05. Right, now we can do it. How we can do it? The value of A. Let's look at value of A. We can get it from the table. So look for the probability value of 0.05. What is the probability value for 0.05?
Minus 1.6.
Yeah. So we can take the average again, as I said. So the value of A is minus 1.675. Simply, if I want to find out the probability of, the value of B, look at the probability for this area. What is the probability for this area? This plus this. So if you look at the probability of Z less than B, right? This B, right? Which is equal 0.95. Why? What is the probability or the area which covered by B? 0.9 plus 0.05. So that means 0.9 plus 0.05. So altogether 0.95. So if you look at the table, look at the probability value for the table for 0.95. Find out the Z value. Definitely it is symmetric, so that you will end up with plus 1.675. So it is symmetric. So the values of A and B are same, only the sign is different. Look at for the B value, 0.95. Right? You will end up with, as we said, roughly that, right? So am I right? 0.05. 625, right? Right? Okay, so by this way, we will be able to find out the probability values, right? Different ways that we can find out the probability values. Clear? Right, now we have seen the table. Now, any questions on the table, looking at the table? I'm going to talk about something different. Any questions looking at the table? You can use the PowerPoint as a supplement notes, right? Any questions? Practical questions. There's one practical application. You see, so right. I will introduce, then I will come to that. Any questions on this? Anyone would like to have? Because up to now we have just seen how to read the table very clearly. Right? How to read the table clearly. Okay. Up to now we have seen how to read the table clearly. Let's see the other aspects. Right. Now, let's say this is a normal distribution. Right. We have the mean value. Let's say I have a value between A and B, say with the value 10 and 15 as an example, right? I want to find out the probability of X, which is in between 10 and 15. What is the probability of X, which is having the range of value between 10 and 15? So in other terms, graphically, we could say in a normal distribution, I want to find out this area. The area enclosed in between 10 and 15. So that is my objective. So I want to find out the area enclosed between 10 and 15. So if you find the area, it will give the probability. What is the problem in normal distribution? In normal distribution, finding area is difficult. We cannot simply find the area unless we have two parameters. But using those two, what are those two parameters? Can you remember in the probability density function of normal distribution? Sigma and mu. If you know the sigma, if you know the mu, then we can find out what is the area enclosed. But it is a long process. You have to substitute on the equation, then you'll have to do the integration of that function, then get the area. You have learned this integration, can you remember in your first year? Area under the curve, right? So that is a long process. So that is why to do the conversion, we are using standard normal distribution. In the standard normal distribution, the mean value is defined, which is 0. Now we want to find out the area in between these two. If you find out the area in between these two, this will reflect the probability of the question, right? Okay, so that is called as Z transformation. So this is called as Z transformation or Z transformation. That is called as Z transformation. Okay, that is called as Z transformation. What do you mean by Z transformation? What do you mean by Z transformation? So from the normal distribution, we want to transform into Z transformation or Z transformation. Z transformation is given as x minus mu divided by Z. So that is the formula for Z transformation. That is the formula for Z transformation. All of you know what is the sign of this. This is the population mean. This is the population standard deviation. This is the random variable x value. Okay. Right. Clear? Right. We will come to a question, simple question, which is on the PowerPoint. We will say, you see here, this is the question. This is the question. Right? You see the transformation. So this is what I said, Z transformation. Right? Z transformation. Let's take an example and go along with that. Let's take an example. This is the example. Right? Can you all see the slide? Can you all see the slide?
Yes, sir.
Okay, good. Right. Now, this is the question. Example, the time required to build a computer is normally distributed. So the time, maybe sometimes they may finish in 40 minutes, sometimes they may finish in 50 minutes when you make computers, different computers. So what we say is the time required to build a computer is normally distributed with a mean of 50 minutes. So the mean value is 50 minutes. So what is this mean value reflect? It is the average time, population mean of making a computer. So you have less than 50 minutes, you have greater than 50 minutes. So the average time taken to build a computer is 50 minutes. And the standard deviation is 10 minutes. Right? Standard deviation. That is the deviation, right? Deviation is 10 minutes. On an average, it is deviating 10 minutes. What do you mean by deviating? Because some computers can 10 minutes less than the mean value. Some can build 10 minutes more than the mean value of 50 minutes, right? So that is on an average, the deviation on an average between the actual time taken to computer building, the deviation, right? Right. So we have those two information from the example. Standard deviation is there, mean is there. Now my question is, what is the probability that a computer is assembled in a time between 45 and 60 minutes, right? So in other term, we are asking the probability in between 45 and 60, right? So basically we said the assembly, the mean is 50. We are asking, let's say this is 45, this is 60. So what is the probability of making computer within the time of 45 to 60 minutes? So another term, so this is 45, this is 60. Probability, find out the probability of x, which is in between 45 and 60. So you want to find out that. So that is the question. Right? Now we have the mean, we have the standard deviation. By having these two, we cannot find out the area very directly. We'll have to apply into that probability density function of normal distribution, then do the integration. It is a long process. But the simplest way, we can convert this into Z distribution and compare the answers. Right, that is what we are going to do it now. Right, what is the probability that a computer is assembled in a time between 45 and 60 minutes? Right, so algebraically speaking, the probability of X in between 45 and 60. So this is the question, right? So find out the value in between 45. Let's say this is 45, this is 60. You can draw proportionately, no problem. Now we are going to convert this into standard normal distribution, where the standard normal distribution mean is 0 and the variance is 1. So that is what we have. Okay. Right. So this is again the distribution, right? So this is what we want to do the conversion. This is where we want to do the conversion, right? The conversion involved with the Z transformation. So look at carefully, how do we do the conversion? That is the probability that we want to find out in between 45 and 60. I'm going to convert it, each of these 45 values. So this conversion is valid, you see. So this conversion is valid here as well as here. So because we'll have to convert in both cases. So we are converting probability of this is the X value, this is the X value, right? Because the first X value, the lower X value, minus this is the mu, mu is 50, minus mu, which is 50, divided by sigma. So that is the formula. Less than X minus mu divided by sigma, which is actually Z, conversion of Z. Then the other value, 60, which is X minus mu, mu is 50 from here, as you all know, then divide by sigma. So that is the conversion that we do. Then you will get an answer, probability of Z greater than minus 0.5 and less than 1. This is after the conversion, right? After the conversion, this is after the conversion. You are just doing the conversion. So now we have simplified this into the way that we can look at the table, as we have already seen. Because now it is expressed in Z. Earlier it is expressed in X, right? So this is normal distribution, this is Z distribution. Now we can find out the answer. Can you find out the answer? Can you find out the answer? As you all know, this is a probability of Z greater than minus 0.5 and less than 1. So that is in a normal distribution, sorry, standard normal distribution. This is what we want to find out. We have already seen similar kind of example, right? So that area we need to calculate. So that area can be calculated as probability of Z less than 1, right? Minus probability of Z less than minus 0.5. So this is the answer. So another term, right? What is the answer? The final answer would be this. So that means P is 0.5328. So what can you say about our probability? Relate with the question. It is the probability of time taken to build a computer in between 45 to 60 minutes. So that probability is 0.5328. All right. 0.5328. Okay. So you have 53.28% chance that a computer can be made in between 45 to 60 minutes. Clear? Is it clear? In computer. Is it clear or not clear? I will take another example. We'll take what is the average paddy production in Sri Lanka? Average paddy production, what is the productivity of paddy in Sri Lanka? Average productivity? Third-year students, right? Agriculture students. What is the average productivity of paddy in Sri Lanka? Per hectare. Per hectare, what is the average production in Sri Lanka? Paddy. Anyone? What is the average paddy production in Sri Lanka? What is the average paddy production? Somebody has sent me a chat. X is equal 55.328. What is that? I don't see the answer. Okay. Right. What is the paddy production in Sri Lanka? Average paddy production. Productivity, yeah? I'm talking about productivity. Roughly about 4.4 metric ton per hectare. 4.4 metric tons per hectare. So that is the average paddy production. Okay. Now, let's say X is the paddy production. X is the paddy production. Average paddy production in Sri Lanka. X is the paddy production in Sri Lanka, which is distributed normally with the mean of mu and the sigma star. So you know what is mean, what is sigma star. This is how we generally write for a continuous distribution or normal distribution, right? X, which is the random variable. In our example, it is the paddy production per hectare. Paddy production per hectare distributed normally with the mu and sigma square. Right. I have an example. The paddy production in Sri Lanka distributed normally with a mean of 4.4 and with the variance of sigma square. Now my question is, find out what is the proportion of farmers, right? What is the proportion of farmers producing the paddy yield less than 4 metric ton per hectare? What is the proportion of farmers in Sri Lanka producing paddy yield on an average 4 metric ton per hectare? What is the proportion of farmers producing less than 4 metric ton per hectare? Simple question. So what we'll have to do, we cannot directly read the table because it is in the X form. So we'll have to convert this into Z. So that is equal. So in other term, in a normal distribution, This is normal distribution, right? Normal distribution. What is the mean value of the paddy production? 4.4. But we are asking 4. This is 4. What is the proportion of farmers in Sri Lanka producing less than 4 metric ton per hectare, right, as a paddy? Okay, that is the question. So the answer is first normal distribution. We will have to convert this into standard normal distribution. So in the conversion, we can say probability of Z when you convert this X, this becomes as Z less than, what is the conversion involved? 4 is the value minus your mean value, what is that? 4.4 divided by sigma. Here we have sigma square variance. So what is sigma then? What is sigma then? 10. Because here we have sigma square. So according to the formula, we have sigma. Right. Now you get the answer. Probability of Z. Anyone? Solve this and tell me it is in minus 0.
0.04.
0. 0.04.
04.
We will take it this as 4.21 because the reason is this value is very low, so that we will take it as 0.0. Sorry, 4.2. This is 4.2. So that 0.08.
2.
Huh?
2.
Right. Now look at the probability value. What is the probability value directly? What is the probability value? Anyone? Any probability, any value? You get the Z value directly here?
No, sir.
No. So what, again, use the same concept as we did earlier. So it is in between Z value of 0 and Z value of minus 0.05. So take in between. So we can take the probability in between that. So what is the probability? Roughly 0.49. Is that right? Get the probability in between 0.49. Anyone couldn't understand the question? This is the time you can ask the question, right? Anybody? So we converted that. So we want to find out in Z table what is the value less than minus 0.02. So here we can't get the less than value. Sorry, 0.02 of minus directly. Then we get the average in between, right? So that the answer is 0.49. So what is, how we can say this in a real text form? Question is, what is the proportion of farmers in Sri Lanka producing paddy productivity is less than 4.2 metric tons per hectare? Now what is my answer? In Sri Lanka, almost 49% of the farmers, 49% of the farmers are producing paddy yield as a productivity less than 4.2 metric ton per hectare. Do you understand? Almost 49% of the farmers producing paddy yield less than 4.2 metric ton per hectare. Right. Now find out the same question. Use the same information. What is the probability of X greater than 4.5. So what is the proportion of farmers producing on an average more than 4.5 metric ton per hectare in Sri Lanka? So that is the question there. Again, use the same concept, probability of x greater than, z greater than 4.5 minus 4.4 divided by 10, 0. So what is the answer for that? Tell me, calculate and see. What is the answer for that? That is same as here.
0.01.
0.01. Right. Okay. Again, what is the problem here? It is in between 0 and, right? In between 0 and 0.05, but much closer to 0, isn't it? Right? Much closer to 0. Giving answer as 0.05 is not healthy. Why it is not healthy? Why it is not healthy? If I ask a question, what is the probability of C greater than 4.4? Sorry, X is greater than 4.4. What is the probability of X greater than 4.4? What is the answer? Do you need a conversion here? Because
8.4, sir.
our mean value is 4.4. So it is
8.4, sir.
equal
8.4, sir.
equal
X value, sir, 8.4.
No, I'm not asking here. I'm asking whether, first of all, do we need a conversion? Because X, do you need to do a conversion here to Z in this example? Do we need to do a conversion?
No.
Yes or no?
No.
Yeah? Do we need a conversion here to find out this value? What is this value? What is this value?
Average paddy production.
Yeah, but you can't say
Mean value.
mean value.
Mean value.
So now tell me, in a normal distribution, if this is a mean, if I want to find out the probability more than the mean value, what is the probability in a normal distribution? It is symmetric, as I said, symmetric.
0.
Yeah. What is the value?
.5.
Exactly, 0.5. You don't need any table or you don't need any kind of conversion. Why? Because this is a mean value. Any value above mean value or below mean value, it is a symmetric. Right? So we can say it is probability is 0.5. So 50% of the farmers are having more yield than 4.4. Right? Another 50% farmers are having paddy yield of less than 4.4. So you see why I am pointing out, looking at the probability of these two. Because here also we say 0.5 or 50% farmer. Here also we say 50% farmers. So it is not logic, right? Even though this value is very small, it is not logic. So what we can do is look at the Z value and P value, Z value and P value. Z value is 0.00, 0.05. What is the value here? Right. What can we do here? Simple calculation. How many minor units
Average.
are, yeah, rather than going for average, how many minor units are here? How many change? What is the change of units? 5 units, isn't it? From here to here, 5 units. Here to here, roughly about, let's say 200 divided by 5. This is 200, this is 5 units, this is 200. So each unit you have roughly about 40. Right? So each unit you have roughly about 40. 40, right? So I can write this as 0.5040 probability value. Can you accept that? Yeah, this is yeah. Other way around, reduction. For this answer, yeah, 4.5 minus 4.4. So that is 4.5 slightly. Okay. So this answer is correct, right? 0.01. I will this is correct, right? 0.01. Right? Yeah. 1 minus 0.0500. Do you agree with that? Do you agree with that? Because we want to find out the area. So let's say this is 4.4. So let's say this is 4.5. So I want to find out that area. Definitely that area is less than 0.5. Do you agree? Because that area is less than the area of 4.4. 4.4 is 0.5. So I want to find out that area, so that 1 minus. Okay. Is it clear? Is it clear? Okay. So this is equal. I will erase this so that it will be more clear. So we cannot find out the greater than directly. So we'll have to say probability of Z 1 minus, because this is a probability of right side, 1 minus probability of Z less than 0.01. So that is equal. Is it? So roughly about, we could say, what is the answer? 49, 0.49, 9, 0.9,
6.
right? 0.4960. So roughly about 49.6% of the farmers are having yield above 4.5 metric ton per hectare. Right? Right. Now find out, using the same example, find out the probability of X in between 4.2 and 4.6. Find out the probability of farmers. What is the proportion of farmers having yield in between 4.2 and 4.6 metric tons per hectare? Find out the value. So this we can convert it directly. Probability of Z greater than 4.2 minus 4.4 divided by 10. Z less than 4.6 minus 4.4 divided by 10. Give me the answers. Probability of
minus 0.022 plus 0.02.
less than. This is minus, right? 0.02 again, right? Is that right? So in other term, we want to find out the range of area. I want to find out the area, right? So this is let's say 4.2. This is 4.6. So we want to find out the what is the proportion of farmers getting the yield in between 4.2 to 4.6 metric ton per hectare. So what is the probability? How we can find out the probability? So here we can say that is equal probability of Z less than 0.02 minus probability of Z minus 0.02. You can write it like that, because earlier we have done an example. So what is the probability of Z less than 0.02? Probability of Z less than 0.02 is this. Sorry. Yeah. Probability of Z is not 0.02, right? 0.02 is we can say 0.0. Can say like this. It is in between value, but I have given the weightage, so we can say it is value between that, right? Minus 0.5 Z 50 4 9 20. Look at the value; it is closer to that, right? These are very close values, right? Do you understand these, how these values are coming? Because look at the probability values of Z, right? So if it has 200 units, if this has 5 units, so per unit change of Z, there's a 40 units change of T. So that is how we say, right? For example, for 0.01, P value is 0.500. For 0.02, we could say 0.5080. For 0.03, we can say 5120. 0.04, we could say 5160. And 0.05, we could say 5199. Roughly, these are 40. Here 40, 40, 40, 40. So look at the table, right? You have this value, you have this value. So I have simply given a weighted value for probability. Not necessary, but you can do it in that way also. So you see here, take the difference here. It is a very minor difference. You will get a probability of 0. What is the value? 0. Here we have 80, 80, 160, 0, 160. So roughly, only 1.6% of the farmers, only 1.6% of the farmers are falling into the category of yield in between 4.2 to 4.6 metric tons per hectare. Any questions? Right. this also, probability, we will do this also, probability of x between A and B, where the probability is, let's say 0.95. Find out the value of A and B. Find out the value of A and B in the same example. Right? We could see probability of A minus 4.4 divided by 10 less than Z. B minus B minus 4.4 divided by 10 is equal to 0.9. Right? So another term, right? If it is a Z value, let's say this is 95%, this is 95%, or 0.95, then this is 0.025, this is 0.025. Now, look at this value is indicating this is normal distribution, right? Here, and this value is indicating the Z value there. So, can you find out the first Z value? 0.025, 0.025 as a probability, yeah? P value 0.025. I will get much closer value, right? I don't take average, I will take a much closer value, minus 1.95. So that is not the A value, right? That is the value in Z, minus 1.95, right? Minus 1.95 is equal A minus 4.4 divided by 10. Right? So what is A then? A minus 4.4 is equal minus 19.5. Minus 19.5. So A is equal minus 19.5 plus 4.4. Right? So that is A is equal 4.4, that is
Minus 15 point.
so that is the value of. Similarly, value of B can be set as, because it is symmetric, you can find out the value if you want 0.95 plus 0.025, which is 0.975. 0.975. You can look at for that value of probability, or otherwise we can take the positive value of that because it is symmetric. So here this is equal 1.9. Right? So B minus 4.4 is equal 19.5. B is equal 23. So you have a range of value. Maybe minus value doesn't give any sense in this example. It doesn't matter. So this is how we find out the value. So the farmers are in the yield between, so 95%, 95% of the farmers are of the yield between minus 15.1 to 23.9 metric ton per hectare. But this is not logic, right? Because these are arbitrary values, some values, not work values. So that's why you are getting a minus value here. Otherwise, you will get a plus value. Right? Right. I will give you some example or the homework. You can try this, right? I can give you the homework to try this. Probability. X is distributed normally with a mean of 10 and with a variance of let's say 144. Right? This is the mean, this is variance. Find out the probability x less than 12. Find out the probability x greater than 11. Find out the probability x in between 8 and 12. Find out the values of a and b when the probability is 0 point. Right? So take this as a homework. Then we will see next week. Any questions? Any questions? Any questions? I cannot see. Let's see. I cannot put it into LMS because these are very large files. The lecture video, then we'll have to give once you come back, because I cannot upload all of this because these are very large files, right? So I cannot upload it in LMS. So we'll have to share it, right? We will see that. I will give it to Vernagoban so you all can collect it from him, right? Yeah. Right, see you then next week. Friday, agronomy from Friday I have a schedule, but I will not take, but people from agronomy department will take that lecture. Huh? Don't give it to anybody else. Right. Okay, bye.
So,
yeah.
So that in previous one, you told that minus 0.02 equal to 0.49 or something.
Minus?
By that, averaging that 0.00 and
yeah.
0.05.
Yeah.
Then after that, you using that changing that 40.
Yeah, you can use anything because
anything.
no problem, because still we accept it. But look at it, if it is very closer to a particular value, use some weighted average. If it is very closer to that, otherwise no point, right?
Okay, so thank you.
You can use either way, no problem. But in the exam, if you take the average, we don't deduct any marks, so full marks will be given, no problem, right? Okay. Any questions? So everybody should be able to know that how to use the table. If you don't use, if you come to a closer value, we don't say you are wrong. But if you give a wrong value totally, then we don't accept it. So do you get the point? So if you have z value, let's say if you want to look at for z value 0.03, where in the table z value 0.03 is not available. 0 is available, 0.05 is available. So every 0.05 terms, the z values are there. So we know if you take the average, fine. Instead of that, if you take some other value, minus 1.00, 0.05, right? Minus 1.05. If you take that value and calculate it, definitely it is a wrong value, right? So we don't give any amounts for that. Right. Okay. See you then.
Sir, excuse me, sir.
Yeah.
Sir, shall we use the Z transformation equation for the standard graph to normal distribution? Can we use it?
I didn't get to your point.
If some questions, sir, we have the standard deviation points.
Yeah.
But can we change the standard form to normal distribution? Can we use that C transformation?
That is not necessary, because all our natural distributions are normal distributions. All our natural distributions are normal distributions. So we want to convert the natural normal distribution to the standard normal distribution to get the value, to get the reading. So there's no point of reversing the process. You understand?
From this question, sir, our question is,
This one.
yes, sir.
Yeah.
Our question is the paddy production in Sri Lanka mean that capital X value, no, sir?
Yeah, yeah.
We found that Z value from standard deviation. How can we find the exact paddy production in Sri Lanka?
No, Z value from standard deviation. No. Paddy production in Sri Lanka is distributed normally with a mean value of 4.4 metric ton per hectare and the variance of 100 metric ton square per hectare. So that is how the information is available. So we cannot find out the probabilities. So that is why we are converting into standard normal distribution. So I didn't get to your point. Yeah, go ahead once again. I didn't get to your points because the paddy production is normally distributed, which is a normal distribution. Now, since we are unable to get the probabilities directly, we are converting to a standard normal distribution, right?
Okay, sir.
It's like the standard normal distribution is similar to our log table. Do you understand?
Then we can take the value as a percentage. Percentage is the final
percentage because probability is given. Total probability is 1. No?
Oh yes, sir.
Total probability is 1. So if you convert 1 into 100, what is that? 100%.
Okay, sir.
So probability is based on 1. If you say 1.1%, sorry, 1.1 probability, it is wrong somewhere. You can't say 1.1 probability value. Probability value is maximum 1, minimum 0. That we have already learned. So in the probability value, we can convert that into percentage.
Okay, sir. Thank you.
Because why we can convert? Because the total area, we consider in calculation total area is 1 or 100%. 1 or 100%. Suppose if I'm calculating probabilities on this 0.5, what do you mean by the probability 0.5 mean? We can convert this into percentage. What is the percentage? Multiplied by 100. So 50%.
50%.
All right.
Yes,
for
sir.
example,
Okay.
so here, when you say probability 0.9, what does it mean?
It's 90.
If you give this in a probability, this is indicating 0.9. So in another graph, I can indicate this as a 90%. Same thing. Do you understand? This is 90%.
Okay, sir.
Same thing. Because here it is 5%, here it is 5%. Here it is probably 0.05, 0.05. So we simply convert it to percentage. So nothing wrong with that. Probability we cannot say in percentage, but take the probability. But if you give a probability just for somebody who doesn't know the probability, let's say I'm telling 0. There's a 0.2% 2 probability of having paddy yield in between 4.3. I would say the paddy yield in between 4.1 and 4.8. Let's say is equal 0.2. What does it mean? If I say to somebody the paddy yield 4.8 metric ton to paddy yield of 4.8 metric ton per hectare is giving a probability 0.2. Nobody understands. If I say 20% of the farmers obtaining the yield in between 4.1 to 4.8 metric ton per hectare, it has some meaning, isn't it? Do you understand? It gives some more meaning than
Yes, sir.
giving, because probability we calculate, but when you explain, you try to explain in a way that everybody should understand. So we can say 20% of the farmers are having yield between 4.1 to 4.8 metric ton per hectare. This brings some meaning, isn't it? But if we say farmers obtaining yield between 4.1 to 4.8 is equal probability 0.2. Will it make sense for people who doesn't know probability? No. But we know, as a statistician, we know. But ultimately, what does statistics mean? You do all kind of calculation. You should bring in the format where everybody understand the numbers and figures. If you just give the numbers and figures, it's no point. So that is why we are converting. As an example, I am telling in percentage. 20% farmers are obtaining yield between 4.1 to 4.8 metric tons per hectare. It brings some meaning. This much of farmers, among 100%, this much of farmers are having yield in between this range. So it gives better information. So that is why we are talking about that. Right, there is another chat. Let's see. What is that? In last calculation, total equation is equal to 0.5. It equal to 1.5 in. I didn't understand. Last calculation, total equation is equal to. Yeah. Total equation is bringing the value of z value. Total equation which I have written brings the z value, right? Yeah, here, right? So here this equation, this is a z transformation, isn't it? From here we are doing a z transformation. So if you do the z transformation, it is equal to the value of z on the table. It is equal to the value of z on the table. So that is why we said a minus 4.4 divided by 10, which is a z value, not the probability value. This z value is same as on the table that we have seen, which is 1.95 or something. This is the table value, z value. This is also z value, not the probability value. So we are equalizing the z values, right? So here also we are equalizing the z values. We are not touching with the probability value. Probability value remains as it is. So it's a normal logic, right? Look at the table, do some exercise. I hope I have some tutorial. I will upload to. I'm not sure whether I can access to the LMS. Otherwise, I will send it to the batch rep or the LMS. You can share some questions like this, right? Some tutorial. You can work it out. I don't know how many tutorials did I send it to you. Any idea? If you keep quiet, better to keep quiet. I also keep quiet. So how many tutorials did I send you? Because I'm not sure how many tutorials. If you need any tutorials, just let me know. Otherwise, I can just leave it. Right. Okay. We will wind up with this. Okay. See you then next week.